take a seat. I just want to say a huge thank you for this YouTube award, for being the most successful YouTuber, for also being the most influential YouTuber and the most scientifically accurate YouTuber. I can't believe I got the award, and I just want to say a couple of thank yous. First of all, thank you to my dog for featuring in many of my videos. I want to say thank you to my wife for the support, the unwavering support that she has given through this journey, and ultimately I want to say thank you to all of the subscribers that have made this channel so successful. I want to say thank you to every single one of you for tuning in and watching every episode that is uploaded. So thank you so much. This award really is for you. Right, did you like that? That is what could happen if we can get up to 1,000, 100,000, 1,000,000 subscribers. So that is a snapshot of the future, and hopefully our future as the family of Mr. Bull's Physics. So if you're watching this for the first time, welcome. Click the subscribe button, because we are currently on 144 subscribers. 144. And if you're new, then and everyone else who's here, we're just a wee recap that we're trying to get 200 by Christmas, and we've changed from the subscribe to like and share this YouTube channel. This is going to help anyone who's sitting their National 5 Physics this year as they hit their tests, as they hit any prelims. We are going to give you all the information you need to pass that course. Okay, so 200 subscribers by Christmas. Welcome to this week's lesson. And today we're actually talking about electricity, the basics. Okay, so we're starting electricity, a new unit. We've gone away from dynamics in space. We're talking about electricity, the basics, and we'll see what we can get covered today. Now, a couple of wee fun things before we do that. Some shout outs. This is a new segment to the video, and we've got 2 shout outs today because 2 people have done some incredible things in the last few episodes. One is a shout out to a National 5 people who is just so in love with Star Wars. They cannot get enough of this show, of this film, of this series, of The Mandalorian, of anything that is out there that is Star Wars. They cannot get enough of it. So what I'm doing, dedicating this to them, a shout out to that person, is I'm asking in the comments below, I would like you to name your favourite lightsaber colour, okay? You know what they are. I'm not even going to tell you. You're a physicist. If you're watching this, you should know what a lightsaber colour is. I want you to comment below, okay? And another shout out is a new segment called a meme moment. And this person is creating memes for Mr. Bull. And this one is when you get 100% in your physics test, Mr. Bull, you can get that if you get 100% in a physics test. Alright? So, if you ever get 100% in a physics test, comment below. And I will try and shout out for you because you're doing 100% in physics. Who does that? That's amazing. Alright, so keep that up. That is because you're subscribing to the channel. Alright, anyway, thank you to that National 5 people. He is getting a shout out for that meme moment. Alright, excellent. Can we get on to some physics? Yes, we can. Alright, now, today we're going to talk about 4 different parts of the course to do with electricity. So we're going to do 1, talk about components of a circuit. Number 2, talk about the charges and electric fields. 3, we're going to talk about the quantities and definitions. And 4, series and parallel circuits. What we're doing today is setting you up so that you can go into this electricity course with all the information you need to answer the questions and to have a good foundation of electricity knowledge. Okay? So, first one, components of a circuit. Nice and simple. Here are the circuit symbols that you will need in National 5 to get your head around what circuit diagrams look like. Now, circuit diagrams are a really easy tool that we use in physics to help us understand what a circuit is, okay? And all of these components help us to understand the different things that are in electrical circuits. So, for example, ammeters and voltmeters. You're going to learn more about that, but an ammeter measures current and a voltmeter measures voltage, okay? We have things like a cell and a battery, which basically give energy to the circuit. We have things like lamps. Now, we don't really use lamps very much anymore. We use these things down here, which are LEDs. You'll have LED TVs, you'll have LEDs in your phone, all of this stuff. We normally use these now, okay? So I've also added that in there. We've got things like resistors and variable resistors. They are always used again and again and again. Anything that you're holding right now, the thing that you're using to watch this, is pretty much using resistors all the time to control the current. And we have things like fuses, which you'll maybe not be aware of, but are in many of your appliances, and we'll talk more about that later. And we have switches, just like a switch on the wall. Okay? So these are circuit symbols, and we need to know these so we can understand what circuit diagrams look like. But you'll get used to these as time goes on. Okay? Now, we're now going to go to charges and electric fields. That should say number 2, don't know why it says number 1 on it. So, we have 2 charges. Now this is not, I'm not making this hard. Okay, this is nice and easy. We have a positive charge and we have a negative charge. Okay? Now positive charges and negative charges attract. Okay? A negative and a negative will repel. A positive or a positive will also repel. Okay? Not hard physics. Things that we would probably be doing in second year science. So like charges, and we have unlike charges. Alright? Now, like charges repel each other, unlike charges attract each other. So positive and negative attract, positive positive or negative negative repel. Okay? Simple things. Now, why do we talk about this? Well, we need to look at kind of the atom structure. Now, if you're a chemist, this will be nice and easy for you. But for physicists, we are only really caring about, in this topic, these wee electrons, because electrons are the things that conduct electricity. They allow electricity to move. Okay, so we're going to be talking about electrons. Specifically, we're going to actually talk about 2 charges, obviously positive and negative, but the directions in which that electric field moves off. So everything electricity, that word is just going to keep recurring time and time again. Okay, so positive, we always have arrows pointing away from positive. Okay, so positive is away. Okay, and the negative is towards. Okay, why? Because we basically make the arrows based on what would happen if a positive charge was to be put into that electric field. So if I put a positive charge, what would it do? It would repel, so the arrows are going away. But if I was to put a positive charge in here, the negative would attract it, so the arrows are going in the way. Alright? Now, what does that look like when we put a positive and negative together, or quite close to one another? Well, you see that there's an electric field, and it's not like straight lines, you actually have curved lines. Electric fields can curve. Okay, so electric fields can curve around. So we have a curved path of electric field where the arrows are always going from the positive to the negative. Okay, so you can see that's how we draw an electric field between a positive and a negative. Alright. So we also know, just like geography, again if you're doing geography you'll know this, where if there's lots of contour lines close together it means it's nice and steep. For this, if we have electric field lines that are close together, then it means it's a strong electric field. Alright? Okay. Another thing that we need to know is that sometimes we get electric fields that have these 2 bars, and you have positive on one side, negative on the other side, and where do they go from? Well, yes, again, from positive to negative. Okay? Not too difficult. All we're talking about is 2 charges, positive, negative, and they always go from positive to negative with the arrows showing that direction. Okay? Now, that shouldn't be too tricky. Components of a circuit and electric fields. Probably very kind of fundamental electricity, but hopefully quite easy electricity. Okay? Now, number 3. Let's talk about some quantities and definitions. Now, this might be a little bit more tricky, because you've not heard any of these things before. This is all new physics. So, the first thing we're going to look at is a charge. Now, charge is measured, or is seen in equations as Q, a capital Q. And it's measured in coulombs. Now, coulombs are, as a guy who obviously kind of found out all this stuff, and I think he was a French guy, and Coulomb, so French, and he measured, or found this out, and said the units were coulombs, so it's in capital C. Alright? So in a circuit, we consider the charges which move to be electrons. So electrons, we're talking about that in the atom. Okay, the electrons are moving around. We're saying that electrons are the things that are moving in a circuit. Now, a little secret. It's not actually electrons that are moving in a circuit. It's something to do with electromagnetic fields. That there is 3rd and 4th year university physics. So I'm not going to go into it. But if you do that, then fair play. Now, coulombs are a way in which we can basically see how many electrons are moving around the circuit. Because there's lots of electrons that we say are moving around the circuit. Okay? In fact, we can find out that there are 6.25 times 10 to the 18 electrons that are moving around the circuit. And we basically say that those number of electrons are equivalent to 1 coulomb. Alright? So 6.25 times 10 to the 18 electrons is equivalent to 1 coulomb. Right? That's not actually the amount of electrons moving around, but we consider that to be 1 coulomb, and we can have multiple coulombs going around the circuit. Okay? So many electrons move around the circuits that it isn't practical, and we want to be practical in physics to use them in calculations. So we just basically say that 1 coulomb is this amount of electrons. Alright? Now, in a circuit, the charges are made to move. Okay, so we have coulombs that move around the circuit. Now, this movement of charge is actually called current, which you may be aware of. Okay, you may have heard the word current before. But current is the movement of these electrons, or movement of these charges around the circuit. Now, current is defined as the number of coulombs, remember coulombs are a bunch of electrons, 6.25 times 10 to the 18 electrons, of charge that pass a point in 1 second. So if I had this classroom here, and I had someone running around the classroom, alright, and they were a coulomb, if they could run around this classroom in 1 second, then that would be 1 amp, because 1 coulomb over 1 second is 1 amp. So we can actually start to create an equation that we're not going to go on to today, but we'll be going on to next week. Okay. Now, that's what current is, and we can see that the charge is moving, and however fast it's moving depends on the current of the circuit. Okay. Now, current is measured in amperes, or capital A for amps. Okay, amps for short. Now, voltage. Voltage is actually a kind of an energy, or an energy being supplied. So when electrons pass through the battery, they are given an electrical energy. Okay, so some sort of energy for the components around the circuit, like the lamps, like the LEDs, like the resistors. So voltage is defined as the number of joules, energy, remember joules, looking back to our last unit, of energy given to each coulomb of charge. Each coulomb comes over, gets given a bit of energy, and then it walks around the circuit and gives that energy off the different components of the circuit. Now, voltage is measured in volts, capital V. Now, you should be aware of volts. You have things like your main supply, which is 230 volts. Or you might think about someone saying like high voltage when there's a big pylon nearby. Okay, so you probably have seen voltage before. So, 4 volts. Let's say I take a 4 volt supply, and one of these wee yellow dots represents 1 joule of energy. Okay, so if we do this, we see that no joules of energy here, but as it comes through the supply voltage, we see that it then picks up 4 joules, and it then passes that on to the coulomb. Okay, so the coulomb then has 4 joules that it has taking around the circuit. Okay, that's what supply voltage does, that's what a battery does, it's just giving energy to the coulombs of charge. Now, we sometimes say that voltage is the same thing as potential difference. That's a fancy word, it's not actually that difficult. Potential difference is just the difference in before and after it goes through the voltage supply. So, there's 4 here, there's 0 here. What's the difference between 4 and 0? 4. So 4 volts. So potential difference is also measured in volts. It's the same as voltage, but we say potential difference as the difference between the supply voltage and the before and after the supply voltage. Okay, so in this case it'd be 4 volts. Now, one of the last things is resistance. Now, resistance is defined as the opposition to current, so opposing current. Okay, and it's measured in this thing called ohms. Okay, which has a wee omega sign as the unit. All right, and it converts electrical energy into another type, to other types of energy. Okay, so it takes electrical energy and puts it into other forms of energy. So when light bulbs resist current, the electrical energy is converted to light energy. Okay, so the 4 joules come in, and then those joules of energy then cause light in the bulb. Okay, and if we just go back, you'll see that then there is no energy left in the coulombs as they leave. Okay. Now, sometimes resistors can become variable resistors. And variable resistors are resistors that you could change the resistance. So for example, if you've got a dimmer switch in your home, have you ever changed the light in your home so it gets a bit dim or it gets brighter? So if you do that, it's actually a variable resistor that's doing that. It's opposing the current. So if you oppose more current, it'll go down. If you oppose less current, it'll be bright. So that's a variable resistor. Now, last thing, very simple, very straightforward, is series and parallel circuits. Now, the last thing we need to know is that a series circuit is a circuit where everything is beside one another. So this is an example of a circuit. This is the first time you've seen one. And you'll have like some sort of supply voltage, and you've got these wires, and you've got this ammeter, and I've got a bulb. Now actually, ammeters must be connected in series. You cannot connect an ammeter that measures current, remember, in amps, and you cannot connect it other than doing it beside something else. Okay, so you need the ammeter beside whatever component you're trying to measure for current. Okay, in this case, it's a series circuit and it's a bulb that we're trying to measure. However, we have another type of circuit, and there's only two, is parallel circuits. And parallel circuits are circuits where you have something above and below. Okay, above and below. So here, they're parallel with one another. All right, makes sense. Now, for voltmeters and for ohmmeters, you must have them in parallel. All right, you must have something above one another. You can't measure the voltage of something's in series. It must be above. It must be parallel. Okay, so an ohmmeter also must be connected parallel, but actually it can only be connected if it's not actually connected to a supply voltage, which is also quite an interesting thing. Okay, so parallel circuits, series circuits. We've looked at. We've looked at definitions and quantities, which we've also had some time looking at that. We've looked at electric fields and charges, and we've also looked at components of electrical circuits. So this is a very, very brief and quick whistle-stop tour of everything to do with electricity basics that I hope is giving you a little bit more of an understanding when it comes to the foundations of electricity, which are really important for this unit. Now, all of this is in a summary here, okay? So take a snapshot of it, take a screenshot of it, and it has everything that I've just talked about: current, voltage, charge, resistance, their abbreviations, their units, their abbreviation of the units, and the definition that you will need to know the definitions of these particular parts or particular quantities. Okay? So make sure you have a look at this, take a screenshot. This is a really important summary that I've just talked about. Alright? Now, thanks for watching. Like and share, and if you continue liking the stuff that I'm doing, a bit of fun, but mostly the physics, then do share and like it for other people to grow in their National 5 physics. But I want to leave you with some final thoughts. A really, really great friend of mine said this: at the end of the day, it's night.